All right. You all ready to get started? Hi, everybody. How are you all doing today? Any questions before we get started? Things that you saw in the video you want to know about? Yes? Yep. Uh-huh. All right, so I've been lying to you about if statements. All right, and I'll tell you, here's the secret about if statements. And it's sort of a style thing, but it's sort of not. If you have an if statement like this, let's just put some Boolean thing there. If you have one and only one line on the if statement, you do not need brackets. So this is legitimate. Okay? This is actually legitimate and real. The reason is because if you have an if statement, you can have exactly one line. Now, what the curly brackets do is they take multiple lines and make them appear to the compiler as one line. So he didn't put the brackets in because I don't remember exactly which example, because he probably only had exactly one line. You don't need curly brackets if you have exactly one line. I am lazy, okay? I am lazy, and what I like to do is not have to ever make decisions if I can avoid it, right? So when I write an if statement, I automatically just put the curly brackets, because then I don't have to think, how many lines am I going to have there or not? I just put it there. And if I only have one line, it's exactly the same. And if I have two lines, it doesn't cause a problem. And here's the other reason why I put brackets. Sometimes if you make this decision, you think, I only have one line, I don't need the brackets. You'll put it there. And then you realize, oh, I need to put a second line of code there. So you'll come back here and you'll put something like, like that. And you'll put the second line of code there. Now what's just happened? Well, what's happened now is that this is no longer inside the if statement. This is a separate statement that if you aligned it properly would be lined up back here. So I always put the curly brackets because I don't want to have to decide if I have to or not, so I just always do it. And then the other thing is it saves me from ever making an error where I go back and add other lines of code to the if statement, and they end up being outside the if statement because the brackets mark where the if statement is. So in Mark's example, he's not wimpy and lazy like me. He's able to make those decisions as to whether it's going to be one line or not, and so he doesn't use the curly brackets if he doesn't have to. I recommend you always use the curly brackets for the reasons that I just said. Sir? Yeah. Uh-huh. Yeah. A compound statement is when you put a whole bunch of things together in brackets. Yes? No, but can you talk me through writing something on the board? That wasn't... When he was doing what? Yep. I'm not sure what you mean by time reference parameters. Time. So we have an object of the time class, like that. And then what? And then we're declaring a method that's part of the time class. Uh-huh. Oh, this is going to be like an IF stream, right? Yeah, we haven't gotten to that ourselves, but here's exactly why. So is this a reference parameter? The first one's not, but the second one is, right? It's going to look like this. Okay, the reason for this is, what is the difference between a value parameter and a reference parameter? Mm-hmm. Right, so a value parameter copies things over, and a reference parameter, anything that changes inside that method or function gets changed where it called from. Does that make sense? So when we're doing input, when we're trying to read from an IF stream and put something into something, we're using a reference parameter here because we want this thing to be changed after the input goes into it. Does that make sense? So we're doing something to this object. We're taking data out of a file or from the keyboard and putting it into this object. And when we're done with this method, we want that data that we read in to still be there. And if we had used a value parameter, it would have copied some value over, we would have changed it here. And then when this method was done, the overloaded operator was done, there would be no changes, which would be bad. We would not like that. Nope. For OF stream, you don't have to do that. What ends up happening is the reference parameter goes in front of the IF stream or the OF stream because that's actually getting changed. So we have a reference parameter in each case. And this is, and I'll get to your question in 1 second. So this whole overloading thing is kind of awkward in C++, and it's one of the things I don't like teaching because it's like weird and complex, and we're doing some stuff and just showing you magic. We're like, just do this magic, and then you look at it and you go, wait, I think I know that magic because I've seen the ampersand and stuff, and I'm like, it's not really doing what you think you're doing. So I don't want you to not understand this. It's just you don't have to understand everything that's going on if you can follow the formula. Is that okay? And that's like one of the only times in this class where I will say that, is that just do this, and it'll work. And this is one of the things I don't like about C++. Okay, you had a question. I'll get to you, Emily. Is this other thing, is this a variable name or is it actually the class name? Yeah, so he's just saying that the parameter for this is going to be a time object. So if I can rewrite this, it'll be like whatever, t. And this is just like we've seen before, right? Like any variable we declare, we have a type, we have a name, and if we want, we tell it it's a reference parameter. This is the class name. Yeah, it's just like everything we've been doing. For when we're using these classes, it's just like everything we've been doing throughout the semester. We say int if we want an int. We say bool if we want a bool. We say double if we want a floating point number. We say time if we want a time object. We say string if we want a string. String is actually an object too, right? And as we're creating these objects, we can create them just by saying the class name and then giving the name to the thing that we're working with. So, yes? Yeah, sorry, I wasn't sure. When I wrote that out, I wasn't sure if she was talking about the prototype or the actual implementation. This is how you will actually do the implementation. With the prototype, you don't need to have the variable name there, but when you actually implement it, you do have to have the variable name. So when we were talking about it before, I just had time ampersand. That's what the prototype would look like. And then this is what the actual parameter would be. Yeah. Yeah. All right, so here's the thing. So in the videos, he went deeper into stuff than I cared to. And in fact, if you go back to YouTube, if you actually go to the YouTube playlist, you'll see that the videos that I have assigned you to look at are not the complete set of videos that he created. So there, if you want to understand that, you can go look at his like 10 or 12 minute thing about why you have to use const after. Personally, I don't really care because it kind of works without, and I'm trying to, on occasion, lighten the amount of material that you have to learn. Not because I'm trying to shortchange you, it's just that I think you're getting an adequate amount without it. So that shows up someplace in the videos, and I don't know, is it confusing? Would you have rather had another like 12-minute video on why to put const after things? Or can you just live with the fact that it's there? Okay. Yeah. Great. Uh-huh. Yeah, because that's a character. If you have just one thing, you can use, it's just a character and it uses single quotes. If you have more than one thing, it's double quotes and it's a string. Again, me being a lazy person, I don't want to have to think about whether I'm just have one character or more. I know that if I have double quotes for a string, one character works as well. Does that make sense? So some of the stuff that I do is motivated out of my sheer laziness, and laziness in a way that as long as I always use double quotes and as long as I always put brackets, I don't actually have to stop and think about whether it's right or not. So, and I like not having to stop to think about things because I'm lazy. Other questions? Other questions? How are the videos going? Are you learning a lot? Yes. Uh-huh. Uh-huh. Yeah. So we're going to do so this is an experiment. We're going to run through the rest of the semester, like all 28 classes or whatever we have left. Just kidding. We have like 5 classes or something like that. I don't even know. Yeah, I didn't mention this is a 2-semester, 3-credit class. You get 3 credits for doing both semesters. No. So we're going to do it, and at the end, I'm going to work with, there's a bunch of people on campus named Candles, which is Center for New Design and Learning and stuff. Center for New Design, Learning, and Stuff, I think is the S. And we're going to get some feedback either through a survey for you all about, like, I don't know, how you like learning and what we could do to make it better for you to learn more easily stuff. Sir. So this is an experiment to a certain degree onto how to do videos that are exciting and engaging. And this is like, that's like, we're working with the rough draft. I am not personally a fan of the handwritten thing. I think if we're going to do it, we should just do like screencasts and stuff. You like the handwriting? So, yeah. So like I said, this is a rough draft. This is something of an experiment. You are little rats running around in the maze to see how well it works, and we're going to ask you how you liked the maze at the end of the class and how we can make the maze better for you. Okay? More cheese, perhaps, would be the answer. But you know, there's like, I really shouldn't spend time. We're like 15 minutes in the class, and I really shouldn't spend time about this. But the entire future of the university system is at stake. Every industry that has had electronic stuff come out has been disintermediated and destroyed. If you think about music, if you think about books, if you think about stuff like that, once stuff becomes available online, the original industry goes into decline. Now we have MOOCs coming along, so the university is going, hey, we don't want to end up whatever we would end up if everybody just started MOOCs all the time, so we need to experiment and figure out what's going to work so that we can compete. So that's kind of what's going on from the high level view. So, and it could be in the end that there is a market, despite the fact that you can go online and watch videos for free, a market for coming in and being able to have me throw candy at you for $800,000 a year or whatever it would cost to do that. So, but this is all part of what the university is trying to do to figure out how to respond to that. Does that kind of make sense? So personally, I'll just tell you my experience so far. I like the flipped classroom, and the reason is that, you know, this is all new and exciting to you, and it's somewhat exciting to me because it's new to you. But at the same time, I do this like all the time, right? Like, I look forward to the point in the semester where I get to say, friends, let friends see their private parts. That's like, you know, one of the high parts of my semester, and because I do this, you know, more often than not. And I think that for me, if we're able to do the flipped classroom, or if we're able to do the videos in a way that is engaging and informative but not overly long, that doing the lecture part once on the video and giving it to you and then coming in and actually doing stuff would be way cooler, right? Because instead of me just going through the stuff I know, you could go, hey, I looked at the video. What kind of weird thing can we do with this? And I'll be like, wow, let's do it, right? Instead of, I don't know, whatever we're doing in here, which is helping you learn things. All right, we spent way too much time on that. Any other questions? Now that I've done with my rant. No? All right, let's see what we're going to do today. My screen went to sleep. Oh, this is kind of bad. Hello? All right, now that we haven't done anything, I'm going to reboot my computer. Oh, man. So the screen capture program I use for recording things, when the screen goes to sleep, it doesn't always want to wake up. So. Whoa, yay, it worked. I didn't have to reboot. Okay. So when we last left off, last class, we were overloading some operators for the point class. And you all saw, I got a little ahead of the videos there, and so you all saw how to do this. Are you all psyched with this? All right? I don't know. I don't know what to do. What do you want to do? So I just wanted to go over this example and finish up and do the overloading for the input operator as well. So you had one other example that's consistent. And anybody want to just walk me through that since you all have seen it? You were brave last time. Oh, I forgot to write my program that picks on people. Oh, that makes me sad. Oh, man. Okay, so let's see. We said, hi, Clay. I'm going to talk about the point class. Okay. All right, so here we are. We're just going to overload the operator. Then we're going to do something else. Do you all know how to overload the input operator? How many of y'all think you could overload the input operator having watched the video? How many of you want another example? Okay, well, the other examples have it. Okay, so what's the deal with friends? What does the friend keyword mean? Yes? Yes, friends let friends see their private parts so they can access private data members. So here's what we're going to do. We're going to write an input operator, and I better use my notes for this because it's been a while since I've written one. I don't want to screw it up because you all know better than I do now, even though you're not admitting to it, how to do this. Okay, so here's our magic formula, iStream operator input, angle brackets, and then we have iStream, which gets modified, and we also have a, point that gets modified, so this is also. So here's our magic formula, and for anything that you want to overload, you can essentially just memorize this and replace point with whatever class you were trying to overload. Does that make sense? So the declarations are pretty much the same. Now, notice again, these things are up at the top of the class. They are not inside the public nor private. What's really happening here is we are overloading an operator not for the point class, but for the iStream or OStream class. And that's why they're declared there. It's a little bit of an oddity. All right, so down here, we say iStream and operator. And why do we not need to put the class construct here? Why don't we need to put point : : here? Yeah? Because it's not of the point class. What we're really working on is something in the iStream class. And we say iStream and input. My angles are the wrong way. Thank you. Did I mention early in the class that I do that all the time? And we're going to have some point that we're going to put stuff into, and we'll call it Z. Yeah, so what's really going on here is that this is not a member of the point class. We're actually extending the functionality of the iStream class. Okay? But the reason we're putting it in point is because we're creating our own class, and we're saying, hey, iStream, when you need to do something, here's a definition of how you work with the point class. Does that help? Okay. So, just like we had output before, we have input here, and you can assume that whatever's coming in will go directly into the private data variables. Remember, when you see this Z dot that says this object is named Z, where does this Z come from? Right there. Yeah, the parameter right there. By the way, anyway, my son watches Super Y. He's 2, and they have letters, and the letter will come in, which letter is the one we have to do? And he'll go, right there! And you can't really tell which one he's pointing at. So I couldn't tell which one you were pointing at, but it reminded me of that this morning. Okay, so there's this Z right there, and it could probably go Z, which Z are we talking about? That point. And dot X means we're looking at something that belongs to that, and X is the variable inside with the same name. So it just says, hey, from the input, stick that in X and stick that in Y. And is there anything else we have to do? And then we return input. Sorry, I couldn't hear you. We could, if we want to match the output format, we would have to do something to match the input format. So if we want to assume that like the output and the input are always going to be the same, we would have to account for all the parens and commas, right? And so I would create a couple of characters. I would say input the first thing into the parentheses, input the next into X, input the next thing into the comma, and input the last into the paren. Do what? No, because what we have to do is if we're reading output and if we're reading input in exactly the same format as we are outputting things, which is not uncommon, what we'd have to do is we'd have to say, look, we have a parenthesis, so we have to read in that parenthesis. We're outputting X, so then we have to read in X. We're outputting a comma, so we have to read in a comma. We're outputting Y, so we're inputting Y. We're outputting a parenthesis, so we're inputting a parenthesis. So in this case, I made it match. Okay. And it depends. You can write this in what format you need. Originally, okay, yes? That's fine. This is just a character variable that's going to hold it, and then we're never going to use it. We're going to throw it away. So this is just a temporary holder. I didn't even have to use the word paren, but I did so that in your mind you could match it more easily. If you wanted, I could call this left paren and that one right paren. Would that be clearer? Okay, let's do that. So we have a left paren, and then we'll have a right paren. And then down here, this one will be the left one. It's wild. And this one will be the right one. Does that help better? Yes. Why do we have an ampersand right here? There? Because it's magic. Just trust me on this. This, like I said, this is like a weird thing that I don't expect you to understand all the complexities behind. I expect you to be able, and I hate doing this because this isn't the type of teacher I am. I don't want you to be able to like vomit formulas at me, right, in response to things. Maybe that was a bad choice of terms, but I don't want you to be able to just repeat formulas. But the easiest way for you to understand this now is just formulaically, right? I stream and operator, angle, angstrom input, and then whatever class you're doing, just put it right there. Yes? Yes. So originally when I wrote this example, I just had the two values, and it would be fine for us just to accept two numbers. Then I had the question saying, well, you're outputting a lot more information because you're outputting commas and parentheses. What if you wanted to input data in that format? And if we wanted to re-input something we had output, we need to account for all these other things that we're spitting out as well. If we just inputted two columns of numbers, we would get rid of all of these things. So it just depends on what format your data is coming in. Yes? No, because this is input, and you can't read input into a string literal. You can do output like this, but when you do input, if you have something, like here's what, if you remember when we run this, I'm just going to run the program without compiling it. If I can remember what it was, point program. So what we ended up printing out was right parentheses 9 comma 9 close parentheses, right? Does that make sense? So if we want to read data in this format, then the only things we're really interested in are the 9 and the 9, these two ints. We're not interested in keeping the parentheses, the comma, or the other parentheses. So what I was showing you in response to a question was, if you want to read data in the same format that you output it, you have to account for reading these characters. And do you remember CN, right? Remember how CN works? Left paren is of what type? And so how many letters or spaces or whatever will it find? 1 and exactly 1. X is of what type? It's an int. And so how many numbers in a row will this take? as many as there are. Comma is what? And it'll take 1. Y is an integer, and it'll take as many as an int, and then the right paren will take 1. So what this will do is this will read the input, assuming that we outputted it the same way. Yes? Uh-huh. Yeah. This would not work for that. Uh-huh. So there's an invisible end of line marker that is treated just like white space by CN. If you use getLine, it gets everything up till that invisible marker. That kind of help. How's everyone doing? Good? Yeah. Okay. So now that we've overloaded this, I'm going to try and compile it, and we'll see if the compiler has found any errors in there. Okay. So I compiled it. It compiled cleanly. And by the way, the magic that I just did right here is in my terminal. If I type H, it gives me the history of every command I've ever typed in that terminal. And then if I say bang 72, it means do command 72 over again. Okay. So if that looked confusing to you, it was just a very fast shortcut to get back to this without having to type it all over again. Okay. So it compiled correctly. We'll run it again and see if it runs. Okay. And it ran. It did just fine. And the reason is because we didn't try and do any input. All right? So it compiled, and we have added input. Let's add a line that does some input now. Yes. Mm-hmm. It does work. It works only because it's a friend function. So often friend functions are one of the things that compilers differ on, so it depends which compiler you're using. And then you might have to declare it in a different place. But on the compiler, the class compiler friend functions work this way. Okay. If you're using, and you're not because you're on your Mac, but if you're using, okay, well, I was about to say if you're using Visual Studio on a PC, on Windows it works differently than this, and you have to rearrange things a little bit. So, but I don't know about it. Are we really able to judge whether things are good or bad? Isn't that really subjective? Okay, can you talk to me about your compiler after class? So, all right, so now we're going to input stuff, and we said, okay, input something in the format XY. Let's create a new point object, and we've used up pretty much every single letter on the keyboard except V, so let's just use V. And then we do CN into V. And then we can see out V and just see what was in there. Let's just put a marker there so that we know what we got. So it's the same program as we had before, but we have overloaded the input operator. We are creating a new point using this overloaded input operator in there and then printing something out. Okay, everybody good with that? I want to make one thing clear because I suspect there's some confusion about it. And I'm just going to make a comment so when it's in the code you'll be able to see it. All this stuff about parens and comma is specific to this example. Okay? If you were just reading data, like data in columns, you don't need it. And instead you can use this. Okay. But because we added some extra formatting, we're reading that formatting again. I'm going to put that in there because I've taught this before, maybe, and I've had exams before where we overloaded operators and people were drawing like commas and parentheses all over the place. And I was like, why did you do that? And then I remember we did the example this way, and it got stuck in their head. So, okay. So everybody kind of good with that? We don't always need to have these parentheses here. This is very specific to the example we're using because we are reading data in the special output, the special format that we outputted it in. All right, so save that. Let's compile it and see if it works. It compiled cleanly. That's nice. We run it. Input something in the format x comma y. What numbers would you like to have for x and y? What? 4 and what? 13. Oh, but I need parentheses because we put those in there. 4 comma. And we print out what we got, and we got our 4 and 13. So now, after doing all this over days and days, we are able to use the input and output angle operators on our objects as if they were ints or bools or whatever. And there was great rejoicing. Yay! No, there was moderate rejoicing. Yay. All right, questions about this? Of course. The actual main, I'm going to upload this onto Facebook as soon as I get home. Yeah. Uh-huh. For any particular, not program, class. So for any particular class that you want to be able to use the angle operator on, you have to define how it works. Okay? For any one. So pretty much for this, it's like not every class we write, but a lot of the classes we write will use it. I don't necessarily recommend that every time you write a class you overload this because that's extra work and you might not ever use it. However, it's very useful for debugging sometimes to overload it. So often if I'm writing a class, I'll actually write the operator first just so that I can use it to debug the class. Uh-huh. Each one has to be done separately. Yes. Yeah. It's able to tell because what it does is it looks at, essentially it goes, okay, I'm doing angle on something and it's V, and it goes, what type is V? And what type is V? It's a point, and it goes, okay, I can tell the difference between a point and a bool, so it knows which class and which overloading to go look at it. So overloading only ever extends functionality, only gives it new functionality. It never takes it away, as long as you're doing your overloading right. So, sir. Yep. Mm-hmm. Yep. If you have that friends thing in front of there, you're able to reach in and get private data members out. The OStream is the friend. So, yeah. So, yes. Mm-hmm. Yeah. Excellent question. The link is that is the final bit of magic that makes it work that I'm not going to explain. You have to, yeah. It works. It's magic. Let's just assume it's magic and move on. Okay. Other questions about input operators, output operators? Yes, but her question is, why do we have to return input at the end? And the answer is, it's magic. Other questions? All right. We're going to do a little exercise because the whole point of doing the flipped classroom is that I don't have to talk all the time, but you can practice stuff. I'm going to hand these out. This is the person class that we've been working with in some other examples as we've been going along. And you are going to write an input and output overloaded operator for them in the next 10 or 15 minutes. Can you pass some back too? And then we'll look and make sure that they work the way that you believe they work. So the nice thing about doing this is that if you can do it here in class for this, you'll be able to do it for project 4, which is due today. It's so much fun to do that. God, one time I had a student come to me and he's like, I missed class, I didn't get my homework in, and I just said, you fail. And he literally went, and I was like, no, I'm kidding. He was like, ah. So by the way, This is totally an exam type problem that I would have for something like this. Just, you know. No. No, you can take computer science 2 without 030, but you can't take data structures in the fall without it. Yeah. Mm-hmm. Yeah. All right, I have some extras. Anybody not get one down towards that end of the room yet? No? All right, so if you look at this, the front is the person class. There's 2 pages of the person class. And then there's an output operator and input operator. You can partner up, you can work together, whatever works for you. And then in about 5 or 10 minutes, we will do them up on the board. Oh yeah, it's important for me to get those back. All right, we're going to finish up in about a minute and do it up on the screen. So. All right, let's go ahead and answer the question, because we have a couple other things to do in class today, briefly. Who would like to tell me how to overload the output operator? Anybody? Show of hands. Great. Oh, just kidding. You look like you're raising your hand, Monica, so I guess you weren't. No apologies. So, what brave person before I actually write my program? Emily, go ahead. Uh-huh. Uh-huh. There we go. So that's our prototype, and then we have to define it, and we'll just do it right here, so we don't have to go so far. All right. Anybody see any errors with that? Sir? Nope. Dot means anything inside the object. It's just that normally we don't really do much with variables. Like, it's unusual for us to access variables directly, but that's what we're doing. So dot means look inside this object and find something with that name. Yeah, Tommy. You could, yes. It's a little bit more efficient, and it gives you an example of how friend functions work, so that if you ever see them in the real world, you will have encountered that before. It depends. How's that? Most often most often these days when we write like big programs, we're not using text input, which we're using in this class. You write like a GUI, and there's like clicks and callbacks and stuff like that that we don't want to do in this class. So more often you're doing other stuff. How's that? Question? Person does not need to be a reference parameter for the output operator, because we are not changing person. Person is staying the same. We're just getting some data out and printing it. So it does not need to be a reference parameter because it is not being changed. Does that make sense? All right, everybody good with this? Shall we see if this one works? Sure, why not? All right, see out, angle, clay, angle, so, okay. So, so now we should be able to output this last thing we made, which is me, because I'm old. And compile that. And we'll test to make sure it works. And it outputted what we put in there correctly, so we're happy. Yay! All right, who wants to do the input operator? I've got a special surprise for the person who does the input operator. Who wants to do the input operator? You want to? Go ahead. Mm-hmm. Okay, so I didn't put the name of the parameters in here because we don't need them yet. I just left them that way for the prototype. Okay. Mm-hmm. P's fine. Oh, you're right. I do need an ampersand. I forgot. Thank you. You are absolutely right. Thank you. And that's the wrong space. Okay. All right, input. We do not for input. And the reason is the angle operator breaks on spaces and takes those out. So. All right. Does this seem correct to everybody? Anybody see any errors? How many of y'all think this is going to work? All right. Let's go down to the bottom and see. So here's your special recognition, person zeta. There you go. And we're going to input and what do we do when we're asking for input? That should be work. Okay, does that work? All right. Work for you? You okay having your name in there? Take it out if you want. All right. So we compile. It compiles cleanly. We will run it. It says input a name, age, and shoe size. You get to choose what goes in there since you did all the work. You can use whatever you like. That's why I'm giving you the You don't have to tell us your true shoe size. Okay. Oh, and something went wrong. What went wrong there? Yeah. Here's what went wrong. I put commas in without thinking, and so it read, and it broke. C and broke. So sorry about that. We'll do this again. And that seems to work correctly. Okay. All right. The other question on there is like how to write a method that reads a whole bunch of things and puts them in a vector. We're not going to do that in class today. However, that is the type of question you can expect about this on the exam. So it would be good to have that as an example. Okay. All right. I would like to go through something not in a lot of detail, but let you take a look at how it works later. I just want to mention it because we have seen it, but we haven't gotten to it yet. And I think we'll go back to the point class for this. So one of the things we have is this right here. What is this that I've highlighted in yellow? A destructor. A constructor is called automatically when an object is created. A destructor is called automatically when an object is destructed, when it goes out of scope. So you remember we talked about scope and where a variable was in scope. Anytime an object goes out of scope and it's going to go away, the destructor gets called. Okay? So what I'm going to do is I haven't been printing that out. I commented out the print statement for the destructor so we didn't have to look at it. But here's what we're going to do. I'm going to comment out this main and we'll write a new main that just does some simple stuff. So I commented out the old main. That will be in the file. You can, when I upload it, you can do what you like with it. I'm going to write a new main. And we're going to create a point P with values 4, 7, and we're going to return 0. That's all we're going to do. Okay. What is this program going to output? Well, here's where do we start? We're going to trace through code. Where do we start? You see int main. What's the first thing that happens? we create a point. When we create a point, what gets called? So we have to go and take a look and see what the constructor does. So we go through all this code and we get up here and we say, aha, here's our constructor right here. And I'm messing up. Sorry, I missed that. And here's our constructor right here. And this is going to go constructing point object at whatever parameters we were given, which were like 4 and 7. Is that what I said? 4 and 12? So it's going to print out constructing object at 4 or 7. Then it's going to return 0, and then it reaches this curly bracket. And what happens at this curly bracket? The point goes out of scope at that point curly bracket. When you reach that curly bracket, the point goes out of scope. So what will happen is that we will see the destructor fire and do that. And what does the destructor do? The destructor prints out destructing point object. So when we run this program now, what we're going to see is we're going to see an object get created and an object get destroyed. Sorry, did I go too fast? Yep, I'm going to put main on the bottom of the screen, if I can find it. There's main, and then I'll put the destructor on the top part of the screen, right there. No, you do not have to call the destructor yourself. The destructor gets called automatically when the variable goes outside of scope. So you know what? I'm going to add one line here. I'm going to add a line right here that says, you know, just like that. Okay, so we'll see constructing object, finishing, and then after that we will see the destructor go. So we'll compile the program. It's happy. We will run the program, and here's what you see. Constructing the point object, finishing, destructing the point object. So we see the point object go away. If we create multiple point objects, we will see multiple point objects go away. So if we wanted to create another point here, and we wanted to create point Q with, you know, 9, 3, and we ran it, we would see both objects get created and then both objects get destroyed. Yes? In this, it's called automatically when the variable goes out of scope. Let me give you a better example, okay? And I was about to do this anyway, but let's give you a better example. So when we have a loop, we can have variables that exist only inside that loop, can't we? Yes? So here's what we're going to do. I'm going to get rid of this. I'm going to change this point Q, and I'm going to say for int I equals 0, I less than 1, I plus plus. How many times will this loop run? It'll run once and only once. We'll say in here create point Q and do nothing else, and then exit. Now, where is point Q have scope? Only inside this for loop. So what we should see is we should see point P being created, point Q being created, point Q being destroyed, and then point P being destroyed, if all goes according to plan. And that's what we see. We see P being created, Q being destroyed, created, Q being destroyed, finishing, P being destroyed. Yes? Okay. Yes. If you don't have a destructor, everything you have in there goes away automatically. But there's a problem. And the problem is something we're going to learn about next. Okay? But I just wanted to make sure that you can see that these destructors are happening, because we're about to start talking about something else. And it's like the last major topic of the semester, which is nice, because from here on out, it's like after we get through this, it's all skating, right? We'll just do whatever we feel like. Mostly, I'll bring in some ice cream, maybe not, something like that. But all right. But for this last topic, we're going to need we have to know something about destructors, and we have to know they happen. Now, I'm going to give you one more problem that I don't want you to do in class. I would like you to try this at home before you watch the next set of videos. Okay? And the answer to this is actually covered in the videos. Like you can just watch the videos and see how this works in there. But I just want you to give it a shot yourself first, because it's actually a somewhat complex example, and it's interesting to try it first before you see how it works. So can you hand those around? Thank you. I'll just give you, sorry, I was going to give you one, and then I'll hand these across. I'll split these in two, roughly. There you go. Thank you. And I was going to do this in class, but I ended up blathering at the front of class, so we'll do one other thing instead. Thank you. Yeah. Yeah, he's on sabbatical. So the answer to your question is probably no. If you want him to do more, that's kind of like the first draft we have. Do you want the code? He might. If you email me, I'll see if I can get you the code to play with. That we can probably do. Yeah. Yeah, if you email me, I can get the code. If he's done a screencast, I'm sure he has it, and I'm sure he'll be happy to share it. So. Yeah, if you email me and remind me, and I'll ask him. He's on email. I saw him. I had lunch with him yesterday. He was on campus, but he's not on campus very much. So. All right, let's take up a new topic. Are you ready? Are you excited? Here is our new topic: pizza delivery. Bet you weren't expecting that. How many of you all have ever delivered a pizza in your life? No one. Good, me either. But how many of you are familiar with the concept of pizza delivery? Yeah, everybody has a concept of pizza delivery. Who here lives in like the same dorm or living accommodation? Anybody? Any people in the class? You too? Okay. Let's say you are going to deliver a pizza to Liv. Would you be able to do it? If I gave you this pizza and I said, deliver this pizza to Liv. Yeah, so he would be able to deliver the pizza there. How are you able to know where to deliver the pizza? Because you know her room number. Absolutely. So which is fine. What are you all laughing about? You know where she lives by name. That's fine. And that's exactly what I was hoping you would say. So if we think back throughout the semester, we've been talking about the computer being a very simple machine. It's simple, but it is insanely fast. What can the computer do? It can take some numbers out of memory. It can put them in the CPU. It can do stuff. It can stuff them back in memory. If you want, it can write stuff out to disk or the screen. That's it. It's dumb, but it's really, really, really fast. So the thing we've been talking about is this memory. Okay? We know memory has slots like this, and things go in the memory slots. And as we've been going along, we've been saying, hey, let's declare a variable. We'll declare something like int x, and what happens? The computer picks out a box that said this box will be x, and anything that we talk about with x will happen with that box. So this box right here has a name. Now, I don't know if you remember this, but early in the semester, I also told you about all these boxes being numbered. And typically, we write the address in hexadecimal, because otherwise it's like 50 digits long. It gets really long, so computer addresses are typically written in hexadecimal. And every one of these boxes has an address as well. Does that make sense? Everybody with me? So, going back to our pizza delivery, you were able to deliver a pizza because you knew the mapping between a name and a particular address. Right? Everything we've been doing in this class is on the basis of name. Everything we've been doing on this class is on the basis of the name. That turns out in computer science to be incredibly limiting. Okay, incredibly limiting. Do you remember the day I tried to convince you all to become computer scientists because it was incredibly cool? And I showed you the trie data structure, right? Where if we want to look up names, instead of looking through a giant list one at a time, we have this thing that's like all the letters of the alphabet. And each one of these is like a little box, and each one of these is a box, and we can follow these boxes all the way through to the end. Well, here's the problem. How many of these boxes are there going to be? Well, if we go by number, then the first, just like lowercase letters, the first one will be 26. And then how many will be down here? And how many down here? And so how many total will there be just for 3 levels? 26 cubed plus 26 squared plus 26. How do we name all of those things? How do we name all of those things? Because so far we've been referring to everything exactly by name. What's the answer? We can't, right? We cannot name this many things and keep track of them as a programmer. We just can't. So we're going to switch a little bit from working with things by name to working with them by address. So let's say that I told you my address was 3904 W Street. Okay? And I said, this is a pizza for Clay. Where are you going to take it? That is not where I live, by the way. I just made that up on the fly. So don't bring me any pizzas there. Okay? So you know my name, and if I say Clay, you're able to say 3904 W Street. What if I gave you a pizza and I said, take this pizza to 3624 R Street? Would you be able to take it there? Who lives there? We don't know, because we don't have a name for that. Okay? Do you see where I'm going with this? So here's what we're going to start talking about, is we're going to start talking about how to work with memory in the computer in a way that the individual variables don't have names anymore. Instead, what they have is addresses. Does that make sense? Now here's the weird thing about this. The weird thing about this is that when we're working with addresses, we have to put the addresses somewhere to work with them. Where do we put them? Inside one of these memory slots. Okay? Inside one of these memory slots. So we have like 2 minutes, and I'm just going to briefly show you something really fast. The ampersand operator, which we've been using to mean reference parameter, has another meaning. It is overloaded. It has another meaning. The other meaning is the address of operator. So I'm going to whip up a really fast program just to show you this super fast. All right, pound include IO stream using namespace standard, int main. Make this bigger so we can see it. Return 0 just to be nice. Okay, so we're going to declare an integer x. We're going to set x equal to 0, and we're going to see out x. What is this program going to output? So we run this and we say it outputs 0. Now what I'm going to do is I'm going to put the ampersand operator in front of that. The ampersand operator means the address of that thing. The address of that thing. What is this going to print out now? A very long numeric address, I hope. And I hope it outputs, yep, it outputs it in hexadecimal. So remember, these things, we have like billions and billions of these little boxes, so the number is very long. But so what we know now is that we have an integer, its name is x, and that it has a value stored in it, it's 0, and we know now where in the memory, the address where in memory that box is stored. Does that make sense? So we can work with names. They're convenient. It's convenient to be able to say, hey, take a pizza to Liv, because we know where she lives. Unintentional pun. We can also take a pizza saying deliver a pizza to 3904 W Street or whatever thing I made up before, and the effect is the same, right? The effect is the same. So the videos you're going to watch for next class go into how we're going to start using this to create things. And I'm going to give you a preview hint. This is the magic behind the vector class. If you've been wondering how vector just sucks things in and works with them, it's using these things before. This is called an address, and the things we're going to be talking about are called pointers. All right, have a good weekend. I'll post some videos for you.